I used the PIR model for this lesson, and basically what I did was prepare students with a bell ringer. And for their bell ringer, I just asked them to tell me what they already knew about wave motion. Then I led students in their own investigation. Basically, they were reading with their partners and then answering focused questions on the different properties of seismic waves. And then finally, I let students reflect by using a Venn diagram or a double bubble concept map. The choice was theirs, where they were comparing and contrasting the different waves. I chose to use the Venn diagram or the double bubble concept map because while they were reading, they started with P waves and S waves. And then before they could get to surface waves, they had to really know the characteristics of both P and S and combine them to form a surface wave. So I thought that by doing a double bubble or Venn diagram, they could kind of list what they had different versus what they had the same kind of toward the middle before combining them for surface waves. By comparing and contrasting the P and S waves, again, the students got the core ideas before surface waves. They had to do this because part of their 8th grade standards are to explain how earthquakes result from forces inside of Earth, and also explain how scientists use seismic waves like primary, secondary, and surface waves. So today's lesson was based solely on the 8th grade science standards. All right, now that you've all had a chance to sort of think about how waves move by drawing a slinky and also skim through a couple of pages and look at the pictures, you should have been able to kind of update your drawing based on what you saw in the book. I also asked you to check off a new standard today that we're working on. We're building on what we learned yesterday about earthquakes with standard 838. So if you haven't done that, check it off on your list. That was part of your bell ringer. Once you read that standard and then look at your learning target, they match up together. Today we're working on modeling seismic waves. Remember we talked about those waves yesterday. So we're going to be talking about the P waves, the S waves, and the surface waves today throughout our read, write, discuss, and notes. Yeah. So when you think about a slinky, you might have drawn something along these lines, or you might have drawn like with a rope, either way. But basically what you want to think of on a slinky is you can move your hand back to forth this way to make that kind of wave, right? But on a slinky, you can also move your hand up to down to make this kind of wave. So hopefully in your drawing you figured out both types, like this and like this. That's what I was hoping that you could come up with for your bell ringer, and we're going to talk about it more today. What we're going to start off with right away is flipping between the F and O section, which is why I asked you to look at both of them. With your partners and your pencils, you're going to start on page 53F where it says P waves, and read that short little paragraph and tell me what they are and how they move. But then they also talk about P waves on page 9O in the first paragraph, and you'll tell me more about them on there. So you're flipping between 53F and 9O to get all of your information on the P waves. Read with your partners and your pencils, please. Go ahead and stop your discussion. So finish up your last thought, your last note. From these 2 pages, hopefully you gained a lot of information about the P waves. As you were reading, some of you answered the first question by saying that P stands for a primary wave. Notice how it's highlighted in my notes, so what should you be doing in yours? Highlight, underline, circle, star, something. All right, so primary P waves was the focus of this slide. Question I asked you was simply, what are they? So how did you define a primary or a P wave, Austin? All right, so you kind of answered the first 2, that you told me they're a seismic wave, and you told me they compress and expand. What I asked one group as I was walking around is, what does primary mean? Like primary school, it means the first school you went to. So primary P waves are the first seismic wave. Remember yesterday we said seismic waves are earthquake waves? When the fault or the rock moves or breaks underground at the focus, the energy gets released. So primary P waves are the first waves that come out of there. When I asked Austin about his definition of primary waves, he told me they compress and expand. So when you went to the O section, I was hoping you saw that type of motion, and I was hoping you put a name to that type of wave. Trey, what did you guys read about for compression and expansion? What was that wave called on 9O? It was the last question that you had to answer. You got it. All right, so everyone kept asking, how do you say that L word? All right, so longitudinal. Longitudinal. You got it. All right, so because primary waves are pushing and pulling back and forth, they're also known as a longitudinal wave. That was from the O section. Notice up here I have a picture as well. I asked you to do pictures in your bell ringer, so hopefully it's kind of coming together. When you push and pull a slinky back and forth like that, it's a longitudinal type of motion or a primary P wave type of motion as well. So primary means first. What comes next? Second, or secondary is what we're going to read about next. When you were on the first page, you notice that they came in order. So remember we were on page 53F. Go ahead and flip back there if you're not there. 53F. We were just there. This time you're going to read the S or secondary wave section. Same notes but for a different wave. So what are S waves or secondary waves? What do they move through? And then on 8O, you're reading about transverse waves in the first paragraph and telling me about their motion. All right, so this time your focus is on S or secondary waves. With your partners and your pencils, go ahead and get your notes, please. You're going to compare and contrast P and S waves. Some people really like to use a Venn diagram to write down their thoughts, but some people really like to use a double bubble to write down their thoughts. I don't care which one you use because you're going to do similarities and differences in both of them. You can use your partners, your notes, and your books to compare and contrast P and S waves. Pick one, talk to your partners, and do it, please. But you can pick whatever kind you want. Both of them do the same thing. It's up to you what you want to draw, basically. So whatever one you feel more comfortable with. During the lesson today, I was basically a facilitator or a monitor. Since the very first day of school, I had groups of 3 in my room, and I'd set them up with expectations that you're going to work with your partners throughout the entire year. It did take a lot of work from the beginning, but I really think it's beneficial to have a group of 3 because it's not just like a one-on-one. If I don't get along with them, then I can have someone else to talk to as well. And also it's beneficial because they're not just copying notes from me on the smartboard. They're responsible for their own learning for each lesson that I give them from their own book, citing the evidence, pointing to it, talking about it, and then writing down whatever makes sense to them in their notes. So I think it's going to help them for the real world, hopefully, when you do have to collaborate with others and kind of take ownership of your own learning. So because I set up these groups like this from day one, I think the students did work pretty well together. They are used to reading, writing, and discussing every day in science that we do notes, so it's kind of just second nature for them to get it done at this point. And as a school, we had focused on concept mapping a couple years ago, so every teacher and student knows how to make a concept map to compare and contrast. So that's why I like to give them a choice at this point, since they already know Venn diagram and double bubble. And then what surprised me later on in the day as well is some people said, well, can I do like a modified T-chart? And I said, sure, as long as you're comparing and contrasting, I'm fine with that. So I was pretty pleased with the strategies today. And that's it.